Hey everyone, welcome to Tutoring. I hope you're having a great day because today we are doing question 11 from chapter 2F. So this is the vector proof chapter and many special students absolutely despise this chapter. But hopefully after watching this video, it shouldn't be too much of a problem for you, or it should make you like vector proof just a little bit more. Anyway, let's get into the question. Question 11. AB and CD are diameters of a circle with center O. Prove that ACBD is a rectangle. So this is what we want to show. AC to CB, back to D, and then back to A. We need to show that that is a rectangle. Clearly it does look like a rectangle, but we can't just say, oh, it looks like a rectangle graphically, therefore it is a rectangle. No, we have to prove it using vectors. That's why it's in the vector proof chapter. So if you want to prove that this is a rectangle, we have to show two criteria. So we have to meet two criteria. One, AD is parallel to CB, or you can do AC parallel to DB, up to you really, it doesn't matter. And the other one, so if you prove that they're parallel and they have the same length, so that AD is equals to CB as well. So if you prove that they're parallel and have the same length, you're already almost there. That's criteria number one, because if these two are parallel and they have the same length, then these other two, so A to C, D to B, must be parallel and have the same length as well. Because regardless, if you have two vectors that are parallel and they have the same length, no matter where you position them, so something like this, you will always end up with the other two vectors being the same length and parallel as well, okay? Regardless. Right, so that's criteria number one. But that doesn't make it a rectangle. It can still be, it's still a parallelogram, right? So the other criteria is a rectangle must have its edges, its vertices at 90 degrees, meet at 90 degrees. So vector AD essentially must be perpendicular to vector AC. In vectors term, if you were to dot product vector AD with AC, or really it can be AD with DB, up to you, they should equals to 0, okay? So if you prove these two, then you prove that ACBD is indeed a rectangle. So let's go with criteria number one first. Right, criteria number one, how do you show that AD is parallel to CB? We haven't been given any vectors, the names for it, so we'll make up ourselves, okay? So let's call vector OA, vector A, and vector OD, vector D, right? Of course, OC will just be negative D, it's going the other way. It also has the same length because it's a diameter. And of course, O to B would be negative A. Right, so we've labeled pretty much all the points we need. Let's get into it. How do you find vector AD? So vector AD right here, A to D, it can be A to O and then O to D. A to O plus O to D. And that is equals to A to O is negative A, so that's D minus A, and O to D is just D. And then of course CB, if you want to find what CB is, that is C to O, O to B, right? C to O is pretty much the same as O to D. It's going the same direction as O to D, so that is just vector D. I'll just skip out this part because I'm pretty sure you know how to do that. And then it will be, so C to B, C to O, and then O to B, that is minus A. So it's pretty much everywhere, it's labeled in our diagram already. Right, the first thing we can already see, vector AD is D minus A, vector CB happens to be the exact same, therefore we can conclude, therefore, that AD is indeed equals to CB. And we can also conclude that AD is also parallel to CB. Because whenever one vector is a scalar multiple of the other vector, they have to be parallel. And that's just the rule properties for vectors, right? So that is criteria number one done. AD parallel to CB, we got it here. AD is also equal to CB. Now, criteria number two, we need to show that vector AD dot product of vector AC equals to 0. So let's write that down here first. Vector AD dot product of vector AC. We don't know if it's equals 0, we have to show that. But we do know what vector AD is already. That is vector D minus vector A, vector D minus vector A, and then vector AC. How would you find vector AC? We don't know that for sure yet, so I'll just write it as vector AC for now. But of course, you can find it just by looking at your diagram. Right, what is vector AC? So to go from A to C, that is A to O, that gives us negative A because it's going the opposite direction, and then O to C, so that's negative D. So that's negative A, negative D, right? Negative A vector and negative D vector, right? And then we just multiply them, we dot product them, FOIL method. D dot product negative A, that gives us okay, and of course we can simplify things. Negative A dot product vector D will cancel out with vector A dot product vector D, and then we have these two terms left, AA and DD. So when a vector multiplied by itself, you get the magnitude square. That's one of the other properties for vectors. Same thing for D right here. So vector D magnitude square. And let's have a look at our diagram once again. What is magnitude of A and what is magnitude of D? So magnitude of A is this length right here, okay? So that is pretty much your radius. And then magnitude of D is also your radius. So they are essentially the same length. So since magnitude of A equals to magnitude of D equals to the radius, we can conclude that vector A square minus vector D square under the magnitude equals to 0. Therefore, AD, vector AD, dot product vector AC equals to 0. Meaning, so yes, a lot of therefores, but that means AD is perpendicular to AC, which is what we need, okay? So that is for criteria number 2. Vector AD is perpendicular to AC. After you've proven these two criteria, 1 and 2, you can just overall conclude, therefore, ADBC is indeed a rectangle. And that's pretty much it, guys, for question 11. Hopefully this video helps you with your vector proof. If you have any other questions, leave a comment below and hopefully I'll try get into it. But aside from that, guys, thanks for watching and I'll see you in the next video.